All right, hello. The Friday. Um, First of all, thanks to everyone who's watching. This is the deep dive. My name is Tim. I go by Foamy Guy on GitHub and Discord. Scott is out this week, taking care of some other stuff, so I'm here filling in, as I will be for the next couple of weeks. I believe he's going on vacation, and so I will be here this week, next week, and the week after. And then I believe he's back after that, although I have not actually talked to him specifically about it, so I'll have to wait and see a little bit. But for anybody new, this is the Deep Dive program where we kind of get down into the nitty-gritty innards of CircuitPython, so to speak. Scott does most typically when he's here. For anyone who doesn't know, Scott is the lead developer of the CircuitPython project. If you don't know what CircuitPython is, it is, well, first of all, you can learn more about it at the website, circuitpython.org right here. This is basically a version of Python that runs on microcontrollers, which are tiny computers. There's a bunch of pictures of them over here. The Raspberry Pi Pico is one of the very popular ones of these devices. They come in all different shapes and sizes, but essentially they are a little computer that is inside these chips, and then there are various different ways you can program that computer. CircuitPython is one of those ways, and if you choose to use CircuitPython, the way that it typically works is you plug it into your computer with a USB cable. It shows up like a thumb drive, and you edit a Python code file that's on that thumb drive. Let me know if I'm too... Whoops. Oh, that is tragic. All right, we need to get that back, first of all. Maybe we'll get lucky with this thing? Ah. Okay. Shout out to the camera controls window, staying alive over there for me. I'm putting this light down just a little bit before we get going here. It's bright in my eye. Okay, so yeah. As I was saying before I accidentally closed the browser, CircuitPython, when you run it on your microcontrollers, you plug it in usually with a USB cable. It shows up like a thumb drive. On that drive, there's a code.py file, a Python code file. You can edit that file with whatever text editor you want. When you save it, the microcontroller, the actual computer that's in these little chips, it will recognize that you modified that file, and it will interpret it for you and execute the code that's in there. These microcontroller devices, lots of them are very generalized. They just have lots of these GPIO, general purpose IO pins, that you can hook up whatever you want to. However, there are some of these devices which are also a bit more purpose built. Like if we search up MacroPad, as the name would suggest, it's a little MacroPad style device. It runs CircuitPython, but instead of being generalized, it's kind of got a specific function of macro keys. So it's got Cherry compatible key plugins. It's got a knob. It's got a little display. You can hook it up to your computer. You can have it launch programs or do hotkeys or whatever you want to do. And so, yeah, microcontrollers, there's all kinds of different ones. There's all different shapes and sizes and built-in capabilities. Look at that one. That's pretty crazy. I've seen that shape before. I wonder if that's a new one. 8086 Consultancy. I haven't seen that one. Maybe it's from searching or something. I don't know. Anyway, yes, circuitpython.org. You can learn more. Scott's the lead developer. He's usually here working on cutting edge stuff. Since he's out, I'm here, and we usually do, when I'm around, not work quite as deep in the trenches, so to speak, as Scott. As the lead developer, he's really working on the cutting edge, whatever is upcoming in CircuitPython, really trying to get it worked out at a very low level, which is not quite where I'm at yet. So when I'm around, we usually work a little bit higher level, either on Python code or libraries, or projects, although this week we are going to be diving around in the core, more like Scott would be doing typically. I will switch to the other tab I had open real fast and set the stage. First of all, let me say hi to C. Grover over in the Discord chat, and Beata Graph over on YouTube. Nice to see you both, my friends. Yes, this tab I have open to the PR that I have been working on this week, which is called TilePaletteMapper module, and then there is a class called TilePaletteMapper within that module, and that is what I'm going to work on today. What this module does is, or what this class does, I should say, the TilePaletteMapper, it works together with a tile grid to allow you to remap colors within individual tiles of that grid. So it's kind of complex when you can't actually look at it. and we will run the code here in a minute. But yeah, so you have a tile grid. Within your tile grid, you have sections of a bitmap. In this case, I'm using the font bitmap. And then what this new module allows you to do is say, for the tile at 0, 0, I would like to map it so that the color index 1, instead of being 1, is actually 0, and vice versa maybe. So color index 0 is actually 1, and color index 1 is actually 0. So you can kind of remap those two indexes to invert the colors. That is the most basic thing that it can do, which is you can actually see the code right here where it's going and saying, I want to update the mapping of the tile at this location, 1, 0. So X, Y, X is 1, Y is 0. We want to update that. The new mapping is now 1, 0. And so that's in index order. So that's saying color index 0 is now going to map to 1. Color index 1 is now going to map to 0. That's the most basic version. But the way this thing works, you can actually declare that you want to use more colors than that as well. So your input bitmap doesn't have to be only 2 bits. It can be more. And your output colors don't have to be constrained by the amount of input colors. So if you have a 2-bit bitmap, you can still map different tiles to different colors, which means you can end up with a multicolor image from what started out as just a 2-bit on and off white and black bitmap, which is really cool. Ultimately, this will be helpful in the terminal. We'll be able to do different colors in the terminal. We'll be able to do inverted colors, which we can do for like highlighting, maybe title bars or something like that, or the cursor in the terminal. Right now, there really isn't a cursor. There are a couple of variables for it inside of terminal.io, I think. I think it's been a while since I looked in there. Maybe I'm misremembering. But I think there are a couple variables or a couple of things where it looks like someone started down the road of implementing a cursor, but it's not visual. It doesn't actually work. It's not hooked up. So this would ultimately give us the ability to have that cursor be like an inverted color of whatever the default is. And then as you arrow around, it changes which tile is inverted based on wherever the cursor is at. That's kind of the ultimate aim, the specific ultimate aim for the usage of this. But now that I have built a lot of it, I actually do realize it's a far more generalized tool, and it can do a lot of different stuff, a lot of interesting things unrelated to the terminal, I think could be done with this. So I'm actually super excited to play with it, as well as excited that I managed to actually pull it off. What's up, Yano? Nice to see you today, my friend. So first thing, we need to get a build, so I will jump to the camera. Shout out to the Nyan Cat Flappy Bird game, the Learn Guide. I have been working on this today, so that's what's on my screen right here. The Learn Guide will come out probably next week, potentially. So keep an eye on Learn if you want to see that when it comes out. I will say one more thing real quick about the hardware. I am Fruit jamming it up. Scott's been working on Fruit Jam games the last couple of weeks, and ultimately that is what I am working on as well. This Nyan Cat one, the Learn Guide, is going live more immediately. Obviously, the Fruit Jam's not out yet. We're still in kind of testing the prototype phase. But the Nyan Cat game can be played on the Metro, and that's what the guide will launch with, is the hardware as the Metro. But I do have the Fruit Jam here for working today during the deep dives. And then I did also want to mention the display, because I think it's pretty convenient, is this 7-inch display, which Adafruit has. It's got a little stand. I don't have the stand connected to it right now. I just have it laying on my desk with the HDMI cable running from the Fruit Jam into it. But I was using the same display with the Metro as well. So again, if you want to play along with what I'm working on, you can actually do so on the Metro. You don't need the Fruit Jam yet, although that is the hardware I'm using to exercise it to get any existing bugs worked out. The Metro PS RAM, the Metro with PS RAM also launched recently, which has the same PS RAM as the Fruit Jam, which makes it so you can load huge sprite sheets and stuff and keep them in RAM, which is pretty interesting. This game doesn't really do that so much. It's not super taxing on the hardware. Okay, but that is not what we're doing today. Instead, we are getting into TilePaletteMapper. Let me pull up the right branch for which I'm just going to use GH, I think, 101.13. That's the PR where this work is in. No repo default. Okay, check this out, and then we want to build it. I'm gonna fess up, I have not actually built it for the RP2350 yet, so hopefully there's no surprises here. Okay. I'm a little jelly. Yeah, the Fruit Jam I think is gonna be super cool hardware. I'm really excited for it to come out as well. Oh. Oh, I think we need to do getting shouty on. We need to do fetch. We need to do this. Here we go. Still no. Oh, it's not in Python. I need to also do this. We need to get the virtual environment. So let's go. Mine is over here. Oop, gotta do this. While that's running, I'm gonna come and copy some test code here. This one is just the 2-color. We'll run that first and then jump into the colors too. We'll want this back. And this is actually technically an old version. Also, I will say too, the like Fruit Jam may be a code name. There may still be a new name for this thing, but I will throw my vote out there to say, like, I think Fruit Jam is actually a really cool name because the other day it occurred to me, and I'm surprised it didn't sooner, honestly. The other day it occurred to me, though, like, Fruit Jam Game Jam is a nice, I don't know, is that alliteration? I'm not sure if it's technically alliteration, but it's just a nice, it rolls off the tongue nicely, Fruit Jam Game Jam. It's fun to say. We'll probably do some Fruit Jam Game Jam type content once the thing does actually launch as well. That'll be pretty fun. Nice. Okay, so we got the build. We're good there. I will go to bootloader, which on this one is boot and reset. This one, I think. Okay. Okay. One thing that might freak this out as soon as it boots is... Actually, it doesn't look like it was that big of a problem. But I was going to say, I think this code that's running might initialize the display. It does not actually. Okay, this is commented out in this one. So that's one difference with absolute newest CircuitPython for both the Metro and the Fruit Jam. Absolute newest has the supervisor.runtime display, which will be automatically configured to your HDMI output, your HSTX ribbon cable, which you can then, well, no, on the Metro it's the HSTX ribbon cable. On the Fruit Jam it's the HDMI connector. I'm gonna check one thing because there's actually another neat thing about this I want to show, but I need to make sure. Okay, yeah, like I need to make sure there's not anything else in my settings file. This I did not know about, but I think maybe this got added at the same time as the supervisor.runtime display thing. I'm pretty sure we owe Jeff a hug report for this, but I'm not 100%. If I got it wrong, my apologies. This is really cool actually too, though. I didn't realize this. You can set the width inside your settings toggle for this Pico DVI auto setup. I don't know if this works on other displays or which other devices or what, but for the Metro with its HSTX and for the Fruit Jam with its HDMI plug, its HDMI adapter, connector, it will automatically configure the display, but you can tell it what size you want. There's a couple of different supported sizes. They're in the documentation for environment. If you look up environment in the CircuitPython docs, you scroll down to the Pico RP2350 section, it will tell you the ones you can use. 320 happens to be what I used for the Nyan Cat game. But I thought that was really cool that you could change it. I didn't realize that. And at some point, the default changed. So I was kind of working with what was the default 320 by 240, but they ultimately figured out a way to make it bigger. They can have 360 by 200, I think. So if your display is multiple of that, then it uses that thing instead. But all of my graphics were already set for the 320 by 240. I was super stoked that I could set it by just putting that variable in there. I think that's super cool. All right, that's old Flappy Nyan. So we are going to take this and drop that into CodePy. And so if this runs, then I'll step through the code. Let me make sure it actually runs before we really step through it, though. Yeah, so it does not run because it was made for the Pi portal. But in fact, we need to do... well, we want a variable, honestly. What's up, Jose Montoya? Nice to see you, my friend. Supervisor.runtime.display. So that's the new like board.display thing, basically. And another cool thing about this is that you can initialize your display in boot. So like if you're on a project where you don't have a built-in display, you could actually, I'm pretty sure, I haven't tested this, so yeah, if I'm wrong, I apologize, but I think you can actually initialize your display in BootPy, and then it lives into CodePy, and it continues living the entire time the device is running, which I think is actually really cool because you don't need your display initialization code in your CodePy or any other stuff you want to run. That can happen once in boot. You don't have to release them anymore at the beginning of CodePy, which was like customary when you had connected displays. You had to release it. I don't think you have to do that anymore. It just lives, stays there. Super cool. Let's see, is there anything else we're going to need to change for this? I think, give it a try. Height is required on... so I updated it to, it needs the number of colors, of input colors. This code is old enough that this argument didn't exist yet, so it's like all the arguments got pushed back by one. So I think we need that right there. Okay, yes, it is sort of. Okay, yeah, I know the last problem, which is that, so, show you the camera so I'm not just like talking about something you can't see. Not that there's much to see at this point. So we have our 2-bit bitmap, our bitmap that's black and white. Again, I'm just using the font bitmap. This is essentially the same bitmap that is used when you use a display text label or a bitmap label. It's grabbing this font bitmap and it's taking chunks of it for each character. I'm not using label here, to be clear. I just have the bitmap and I have it in a tile grid for testing. And the one reason I believe why this is still not working is in the code here, it's trying to like invert, flip-flop these things, but these got changed to tuples. They're no longer lists. So the if condition needs to be a tuple right here. Yeah, there we go. and now this little invert action goes on. So check that out. That's super cool. Let's scale it up a bit because our screen is super huge. That's not how we scale it up, though. That is also... Go. Wow. That is freaking out the camera. That's actually really funny. Huh. Okay. So that's the most basic use case where we can invert these tiles. And this one is not broken, by the way. This one is just set separately. It's just like that for testing. Like this line right here is setting 1, 0 to be mapped as 1, 0, which is backwards when it first starts. It's inverted. And then this code in here is going through, and for every tile, it's swapping it. It's saying if the current tile is mapped to 0, 1, then change it to 1, 0. Else, if it was not mapped to 0, 1, then map it to 0, 1, which in this case is just going back and forth, inverting that particular tile or not. But the real super duper cool stuff, this is pretty cool, but the real super duper cool stuff, in my opinion, is actually the next one down. And I have to say shout out to Scott, Hug Report for Scott, who had kind of the idea for the way this could work, which ultimately was really good, I think. Much better than what I put together initially last week. And I learned a lot from both. I learned a lot from doing it last week. I learned a lot more from doing it the new way this week. Let's make this inverted TPM test. And now we can get the color one. Let me actually one more thing I'll do before we get all the way into the color one. Let me step through the code real fast, just because I think I showed a little bit of it, but let me just step through so you can see like what's actually going on here. Sleep is not important. I just had this because I was working inside the core, and if I managed to hard crash it, I wanted a second before it would hard crash, and I'd have time to like stop it or whatever. Two color palette, black and white. Black is 0, white is 1. This is just the size of, I don't know, the size of one character, basically, like one character in the font. I think is 6x12 for the default font if memory serves, but in any case we have a variable for it. Main group, that's, you know, straightforward. Display, we set the scale to 2 now. Show, you know, use root group to show main group on the display. Here's our new thing, TilePaletteMapper. So we create one of those. You need to give it a palette. So I'm giving it this 2-color palette right here. You need to tell it the number of input colors that are in the bitmap, which is the number of colors that exist inside the bitmap that is on the tile grid that you are going to use this with. In this case, that matches 2 colors here, 2 colors here, but they don't have to. We'll see in the next example one where they don't match. So that's the number of colors in the bitmap. That is the width of the width in tiles for your grid, and then that's the height in tiles for your grid. So we have, in my case, 10 wide, 4 tall. Then we create a tile grid, which of course we give it the bitmap, we give it the pixel shader, and that's where this TPM, TilePaletteMapper, comes in. We put that where we would put the palette. So instead of the palette, now we put the TilePaletteMapper. We give it the tile width. In our case, again, I think that's 6x12, but it's, you know, whatever we got from the font back up here. The width, again, 10x4, that's the same thing. So the default case, you kind of want these to match, although it does work if they don't match. You'll just, like, it won't go outside the bounds of the mapper. And then default tile, we just set to 0 for this one. Append that to the main group. This is just looping over every tile and setting that tile equal to its index, which is why we ended up with, like, you know, all of the characters and then like 0 through 9, and then like we started the alphabet or whatever. Those are just listing off in the order they appear in the bitmap. So, which is probably correlated to ASCII. But whatever order they're in there, we're just setting them into the tile grid so that we have something to look at. That's where we're inverting the tile at 1, 0. and then we go into our main loop. We loop over every tile in the grid. The current tile gets put into this tuple. That way we can update it right here to say we want to change the current tile's mapping. That's where we do the swap. And then there's a little bit of a sleep so that it kind of gives it a motion effect as it goes. If you don't sleep, then it goes really, really fast. You can't really see it. Okay, next code, which did not run, so let's make it run. Module has no display, so yeah, we'll fix that. We can just copy that. I'm going to copy the scale. Oh, the scale is, this one's actually already scaled up. Whoops. Install anything. Let's see. We have the colors already here. So yeah, here's one where this is different. So we're giving it the palette, but this time our palette has 258 colors in it. So the first two are the same. 0 is black, 1 is white. But then the next 256 all come from rainbowio.colorwheel. And so we basically pass I into color wheel to get the next color of the rainbow. Rainbow IO color wheel, for anyone that doesn't know, you give it a number between 0 and 256. It gives you back a color. As you move through 0 to 256, the colors you get will be rainbowy, right? So we're setting those into the palette. This part's the same. We get the size of the font. We're at scale 4 this time. Tile palette manager, we create it. And so here's where we have the difference in the number here, though. So now our palette has 258 colors in it, but our bitmap actually only has 2 colors in it. We're using the same bitmap, which is still just black and white. So 2 colors in the input bitmap. Size is the same, 10 width, 4 height. Get our bitmap, we put it there. We put our tile palette mapper there. Same stuff for all of this. Same thing here. We're setting those tiles so that we have something to look at. It prints a couple of things out. It does invert the first one. The one at X index 1, I should say, which is kind of the second one in my head, but whatever. And then it goes through and does this little sort of rainbow back and forth action. So it's going through all the tiles and it's setting the current tile essentially to a current color of the rainbow. And then for each tile, it's updating it so that the next tile will get a slightly different color. And it's going all the way forwards through the tiles, and then it's going all the way backwards through the tiles. So it kind of like goes one way, updating colors, and then it goes back the other way, updating colors, and then it goes the other way, back and forth. We should be pretty close to being able to have it run. Yeah, in fact, it is running. So there you can see it kind of runs back and forth through the rows of the tile there, of the grid, I should say. And so this is super cool because, again, we have a bitmap which is only 2 bits, black and white in the bitmap, but we're able to achieve like rich multicolor output when it gets to the display, which gives us a lot of capabilities. I think you can achieve a lot of interesting visual effects this way. Shout out to Anne B put out a learn guide this week for the matrix, the kind of raining matrix text, and it was built with Arduino. And I think that this kind of thing would actually give us the ability to do that in CircuitPython as well. I have it going through the whole rainbow here, but we could of course use like, you know, bright green, dark green, middle green. Like you could have a gradient of greens as your color. It doesn't have to be the full rainbow. And then we could do the whole raining text and everything in CircuitPython as well, which I think would be cool. Okay, so this is working, which is cool. Now you've had a chance to see what it is. If anyone has questions, comments, ideas, anything like that, throw them in the chat. I'm happy to talk about it. I kind of put this together this week, so it's all on the tip of my brain right now. The thing that I want to work on next is... I think I want to work on color converter first. So in the PR, There are two things that were mentioned that are not done yet, which are support for color converter. Right now, this is palettes only. And then another one is make it more efficient. Right now, it stores an array of numbers even when your mapping is like not really mapped. Even if you map 0 to 0, 1 to 1, 2 to 2, so on and so forth. So it's like it's not actually changing anything. This is currently like using memory to store that mapping, which is not great. We could make it better by storing like null and have null mean no mapping. And then for any tiles that aren't actually mapped, we save some space. Helpful to simulate neopixel or matrices easier. Oh, interesting. Yeah, you could do, yeah, you could totally do, you know, somebody did at one point like a display.io neopixel wrapper type thing where it drew little colored dots for the neopixels. This would let you do it with letters, which would be pretty cool. So color converter, I think I would like to attempt. That's what I am going to try to work on right now. And I'm going to make a new branch for it. And I'll start it, I think I'll start it from this one. And I'll worry about if this gets merged later and then I need to go back and change it. That's a thing I can do still, but I will say TilePaletteMapper color converter. I don't want to work on the same branch though, because I'm not sure how quickly or easily we'll get it to work. And I would like to keep that one branch working and in the PR there. Okay, so we're gonna need to get a couple of things open here. So definitely one place where we need to look at is tile grid in shared module, because this is kind of the business end of like where we need to like actually get colors from the TilePaletteMapper. It's going to be inside of, I think, fill area, pretty sure is the name of this. And not fill area. No, there it is. Okay. Okay. So inside fill area here in tile grid, this is really where the pixels come out of the bitmap and go onto the display ultimately. And there's a little bit of logic for like, if the pixel shader is none, then I didn't know you could do that, but it just sends the pixel straight through with no change. I think it might raise an I don't know. I think it might raise an exception if you put none for the pixel shader, but I'm not sure. More typically, you would see the pixel shader is like a palette like this. So if it's a palette, then it's going to do palette.getColor. Or the other option, more typically, if the pixel shader is a color converter, then it's going to do color converter.getColor. Well, convert rather. And then it goes on to do a bunch of other stuff for like hidden and opaque and flipped and mirrored, and all kinds of stuff happens all inside of this function. But the color is the main thing we care about here. And so in order to do color converter, what we're going to need to do is go inside of TilePaletteMapper getColor and add the code that basically looks like this, where it says if the type is palette, then do it this way, and if the type is color converter, then do it that way. Before we can even really do that, though, we will need to actually be able to put a color converter onto it. And so I'm going to start. This is kind of like the bottom of the chain. In my mind, this is like where the code gets used by display.io to like make stuff happen visually. The opposite end, the top of the chain, in my head, at least in my mental picture, is in shared bindings, where the Python code starts out, right? The Python code is hitting shared bindings, it's getting validated and everything. Then it's calling into shared module. And ultimately inside tile grid here is where it gets to the display. So we will need Okay, so that already just returns an object. That'll be fine. I guess we probably should call it a pixel shader and not a palette, since it could be then both, which is going to change like the API and everything. But this is all brand new still, so that's not a terrible thing. Spent too much time in this code before. Nice, yeah, I've been in it a bit, but much more in the last 2 weeks for sure. So I'm not going to worry about the name right now. I'm just going to leave it called palette, but I'm going to make it start working for a color converter as well. And eventually I think we'll come back, and that should probably be pixel shader so that it matches the naming of like how TileGrid works. And so here it is testing if it is a palette type, and we can just also that not or? What is or in C? Oh, well, it wouldn't want the comma. Did I put that comma? Well, actually, it would be and, because it's not type. So if it's not a palette and it's not a color converter, then it is invalid. Probably need to import a thing for that. That work? Looks like that worked. Yeah, okay. Okay, so now we can pass it into the constructor, and it won't just immediately raise an exception. We also on set palette? No, there is no set palette actually. Okay, so we don't need to worry about that. We would change the signature of this. This could be union be this now. Also, that could change up here as well. I don't remember how it wants this indented. I'll have to see if that throws it off or what. Okay. Okay, let's just like I'm a big one step at a time in the core. So I am going to try to build this first of all, see if it even builds. If it builds, then I'm going to put it on the device, and what we're going to do is try to just instantiate the thing with a color converter, and that's it. We won't do anything past that. I'm going to comment all of this out, and we'll say color converter. Let's do the default one, which is 888. Like if I save this right now, it will not work because I didn't put valid syntax. But it will tell me unsupported pixel shader type. Well, that's interesting. It's already saying pixel shader. I guess I probably copy pasted that. All right, well, that's convenient, I guess. So yeah, like while I was working on this, I was very much just like do one minuscule thing at a time. Like I literally made it an empty object with nothing, flashed it on the device, instantiated it, made sure that it didn't crash. And then I added like one thing. I added like width only, and I made it so you could set the width. And then I added the height, made it so you could set the height, and then made it so you could get the width and height. I took it very, very slow, one step at a time. What boards will have this functionality by default? I don't fully understand how the entire build flags thingy works. There is a new one of these for it. The boards that I turned it off for were any SAMD21. It overflowed pretty much all of them anyway. I don't know, like maybe there was one or two that technically could fit if you did it in the right language and you turned off something else or something, but it basically overflowed all the SAMD21s. So it's turned off right now by default for all SAMD21s. And then it is turned off for a couple of SAMD51s, which had overflowed. The Circuit Brains Deluxe, the Data Lore, the Hallowing Express, Itsy Bitsy M4 Express, Open Book. This is an e-ink, which I guess you could still do invert anyway. Pew Pew LCD, Silly Cognition. I'm not familiar with that one. UART Logger 2. Everything else that is a SAMD51, it should be supported on. And I think that everything else it's enabled on, but I don't really understand exactly how the whole build system works. I will say the other caveat is you have to have display I/O. I set it to say like it's off if display I/O is off. So any device that doesn't have display I/O, this will be off by default. But it's like doesn't do anything without display I/O anyway. Okay. This worked this time, I think, right? We instantiated, the code doesn't do anything, just finishes, but it doesn't raise that exception anymore. So it allowed us to put the color converter on our thing. It allowed us to put it in the constructor specifically, right? Don't really need this. Yeah, we passed in color converter there. Okay, perfect. So next we want to use it inside of TileGrid. But in order to do that, we actually need to use it inside of shared module, TilePaletteMapper, get color. Get color. So right here, we currently say get color. Oh, wait a minute. So this is the bounds check. This is saying if the tile that we are, so like this get color code, this is getting called from TileGrid inside fill area, and it's getting called on every pixel. But it is passing in the tile coordinates as well. Input pixel has the pixel coordinates. Output pixel is where we're going to write the color to when we're ready. And then these are the tile coordinates within the tile grid. But this is getting called on every pixel. And so this is saying, essentially, if the tile coordinates that were passed in are outside the width and height of the TilePaletteMapper, then it essentially doesn't do any mapping. It just gets the color default way. We don't do anything special. It just is as if the mapper wasn't there. So here we will need to say, like, if it is a color converter the same way. Why is this shared bindings? Why is this not, did I not change? Oh, right. We didn't, yeah, no, we didn't change anything in here yet. Okay. Yeah. Okay. So we basically need these things. So if it is, it's not, is it this? It is this. I don't know, why is it red? I don't know why it's red. No member? Oh, well, actually, it's palette. My bad. On here, but I'm gonna rename it eventually. So we'll see. So if the palette is a palette, then do it that way. Else, if it is a color converter, I'm gonna do it this way. And then I don't think I'm gonna bother supporting none. I know that one has none there. don't think I'm going to bother doing none on this. Oops. Okay, we need color converter type. Woo. Shout out, we had C Grover here earlier, right? Yeah, shout out to C Grover, by the way. I was so I'm a big my podcast and my audiobook consumption is primarily while I walk. It used to be while I drive, and now I've been working from home for a few years, so I don't drive that much. And it became while I walk, but it is winter where I'm at, so I have not been walking too much, but it's starting to warm up. So I've been walking the last couple of days. I've been catching up on podcasts. Shout out to C Grover and Paul Cutler, CircuitPython Show podcast. I was listening to that one the other day with C Grover about the weather station, and one of the things that was said in there really stuck with me about it was drawing a comparison between building your UI, your visual layout, and kind of a magician's trick. I think of display layouts and stuff like that in that context a lot as well. I thought that was a really apt comparison. But check out the CircuitPython Show podcast for anyone who hasn't. That one is with C Grover a couple of weeks ago, and there are a few more as well that have come out since then. And I will be on one of them coming up in April. We'll plug that one as well. I forget the exact date. I don't remember if I was told the exact date or not, but I remember that it's in April. That was the trash can lid falling, if anyone heard that. Definitely took me out of where I was at. Okay, yes, we want to, so if it is a color converter, we want to basically get it this way. Whoa. So the thing that ties that together, working on this thing, like the way that it allows you to go from one, 2-bit color, black and white, into full color in every different tile was reminding me a lot of that concept of like the magic trick to be able to achieve visual effects. Thought it was really apt for this. Those are not addresses because we passed addresses into this, so we just put those straight through, I think. It does call it output pixel, and it got renamed here to output color, but it's the same thing. It's technically a pixel. Not sure why this one... Not sure why this one calls it a color and the other one calls it a pixel, but it's a pixel object in any case, or pixel struct because we're in C. Pixel type? I don't know if it's a struct. Not sure if my terminology is correct. I've gotten good enough to use C for stuff, but I would not say that I'm like have all the terminology down. Okay. Yeah, so that should work fine, I think, for the out-of-bounds ones, and then we will basically do a very, very similar thing here for the inbounds ones. It's just the difference is we use temp pixel instead of input pixel because the temp pixel stands for temporary. That one is where the mapped color is at. So if we are out of bounds, we do the lookup as normal and we return, so we finish. If we are in bounds, we get the tile index, which is basically taking the X and Y and getting it into just that single number index as though it were in a list. We get the mapped index. This is actually the mapped color index, which it goes and it says we want to get a value from tile mappings, tile index, and then we want to look up the value of input.pixel, which will be the color index. So like in our 2-bit bitmap, this will either be a 0 or a 1. If it's a black pixel, it'll be 0. If it's a white pixel, it'll be 1. And so we're getting the mapped one. We're ultimately putting that into this temp pixel, and then we pass that temp pixel along to palette.getColor. So it's gonna get well, I don't even think it necessarily, I'm not sure. I haven't looked inside. I'm not sure if it actually needs the pixel or what, but it's gonna basically, well, yeah, it needs the pixel because it's gonna get the color index off of it. So, if it was a 0 before, we're remapping it here, but in any case, inside of here, it's going to go and get the pixel color off of it, run it through the palette and the color space, and then set it onto the output pixel. Which TileGrid has all like kind of orchestrated this and is waiting for us to do this basically. Like, we're going to do this and then it's going to send it to the display for us. Okay. And then I don't think we need to worry about an else here because we are inside of get color, and we still have shared bindings, which would not let you give it a different type, right? So if you give it a string or a number or whatever instead of a palette or a color converter, it's going to raise an exception on you before you ever get to here. That was a really good episode. Very cool to hear about the evolution of the weather station project. Yeah, for sure. Definitely agree. Okay. That might be all we need, really. I think we should check in the mappings. So the mappings are what again? We have enough space. So, okay, so tile mappings. This is a pointer to an array, or to like a list essentially of pointers. Each one of those pointers goes to an array, or list again of pointer essentially. Multiple uint 16s. So the question though is, do the numbers that come out of color converter fit inside uint 16? Do not know. Because if they don't, then this actually needs to be bigger in order for us to be able to store like colors instead of just indexes. We are going to find out by looking here. Oh, that's interesting. Convert color. Oh, that's what... Wait, is that what we're calling? Okay, hold on. There's a color... There's a convert? Did I copy that wrong? No, okay. So there's a convert. But then there's also a convert color. Doesn't require a color converter object. I don't even know what that means, really. I mean, I think it means it's being used from C code only, not Python land, but... is this... shared module, okay. I mean, does this get used anywhere? It's used? It's used by like an e-ink display or something. It does get used once inside palette somewhere. It's inside palette. That's interesting. Oh, inside. Right. Okay, so inside palette, like ultimately we still need to get to like 565 color space, I'm pretty sure, because I think display IO for most devices, I'm pretty sure, is intended to output to 565 color space. All of our Python code is 888 color space, right? Like FFFFFF, that's 8 bits for each color. But I think internally that's going down to 565. And then palette is probably using that function to do that. What was the line of that? 77. Yeah. So yeah, totally. So inside get color here, we are going to get the color from our list of colors, but then ultimately we are still going to go and convert that color. from the input color space of 888 to the default output color space of color converter, which is 565, I'm pretty sure. And then it will ultimately set the color there inside the pixel. Okay. But in our case, I don't think we need that. We can use the same one that TileGrid is using, which is color converter convert. Not convert color, just convert, which is not declared in shared module.h, which means it must be probably declared in shared module 8, shared bindings h. Convert. But that's a common HAL. We're not using common HAL, are we? One thing I will say that's still a bit mysterious to me is there's like this instance where we have a convert and then we have a convert color and then we also have a common HAL display IO converter convert color or whatever. We end up with different versions of functions that sound the same on the surface. It's not actually declared here though, so that's interesting. Oh, there it is. Okay. So we have converter, convert, which is the one we're calling, which is here. And then this one. So it's basically, it doesn't have a self, which makes sense. It doesn't require an object. Okay. It's like a static version of the same thing, pretty much. Interesting. I didn't know you could do that. Okay. It's kind of cool. Okay. In our case, we have an instance, so we're not using that. And we're just going to call the same thing. So this may just work. Sorry, so I got a little bit off track there. We wanted to find out the size of the return, but that's trickier because this doesn't actually return, does it? So it's just setting onto the pixel. So I guess what we need to know is the type of output pixel.pixel, which comes from here. Okay, so that's uint32. So yeah, that's a problem for us because we can't store uint32s currently. And we need to be able to store them so that they can be in the mapping, right? Because the whole idea is to be able to go and say, like, for tile index 0, the mapping of color index 0, we're going to change it from black to red, maybe FF0000. In order to be able to do that, we got to be able to store that in our list there, our pointer array thingy. Tile mappings is the name of it. Yeah. We do just take it out of here and set it into a uint32, which is interesting. Okay. Let's compile that and see. Actually, and then we'll run it, see if it instantiates. We'll kind of do the same thing. We'll take it one step at a time here. Okay, so yeah, it's not gonna work because we changed the type of that. So, oh yeah, that would be bad, wouldn't it? Okay, let's fix that. So we need to make the correct amount of space for it when we allocate memory. That'd probably be a good thing. This one might not need to be this. But I will say this is like right on the... This is right on the boundary of my knowledge, pretty much. Yeah, I think we do need that because we're basically saying... Yeah, we're casting the thing that we are allocating. and we want it to be this because that's what we just told it was in the struct. And then same thing here, essentially, we're casting the thing we're allocating, except this time it's not a double. We're not going 2 layers deep, we're just one. But our size will still be this as well, though. And then this probably should only happen. That's gonna get weird, but I think what we do for now is let's just wrap this in one of these. So this is setting the initial mapping for each tile. And right now it's setting it to basically just be no mapping. It's saying color index 0 maps to index 0. Color index 1 maps to 1, 2 maps to 2, so on and so forth. But that only makes sense for a tile. I mean a palette, rather. If it's a color converter, if it's a color converter, I mean, to get some code that works and does something, I'm just going to set them all to black, I think. But at some point, we'll need to probably do something more clever. Well, really, this gets to the other of the two things, right? Remember, the two things were color converter 1 and storing null when there's no mapping, which will come into play here as well. Because we'll start with no mapping, which means we'll start with null. As a result, though, if you don't set a mapping and you're using a color converter, I don't think the thing is going to be visible, really. You're going to get a lot of shades of almost black. Because 0 is going to get mapped to 0. But so is, like 1 is going to get mapped to 1. 2 is going to map to 2. But colors like 0, 1, 2, 3, 4, 5, 100, 1,000, all of those colors are very close to black still. You got to get fairly large before you start brightening up some. Yeah. I mean, I think that's kind of a consequence of using a indexed bitmap with a color converter pixel shader. Like, nobody knows what color you want, so we can't really set sane defaults, really. I mean, for 0, like, we could do 0 and 1 for white and black, which is fairly customary, but black and white, rather. I don't even know if it's worth doing that, though. I'm going to start them on 0. Okay. Continues to be a fun and challenging project. Looking forward to your guest appearance on CircuitPy Podcast. Have you already worked out a topic? Yeah, yep. We've done the topic. I've already recorded it. It's about games in CircuitPython. It's about some of the games that I worked on in 2024 and some of like my approach to making games and just all about CircuitPython and games. I was reminded so often of the dictum told to me as a student to express my own students. Writing is never done its due. Yeah, there you go. Like that. Okay, let's copy that. We can go to bootloader. All right, and so again, our code currently just instantiates it and doesn't really do anything. Instantiates it and doesn't do anything. We could try doing something slightly. Anything goes terribly wrong. Well, first of all, let's put the palette back and just try what we had before and see if that still works or not. Very possible that we messed that up. But pleasantly, it seems as though we didn't. Okay. We are probably using, twice as much RAM now because we're storing those in 32 UNT32s, but that is okay. And then what we'll do now is go comment all that back out again. Color converter, and then let's just do let's do some of this. So let's do that part. And these. And yeah, this and is going to give us colors that we can't really see, I believe. Oh, mapping value must be 0, -1? Is that trying to say 0 to -1? Oh. Yeah. Okay, so when you go to set a mapping, there's actually validation, and the validation is wrong now. Yeah. Okay, so this is validating the length of the thing you passed. But that was fine in our case. Mapping value, not mapping length. So we need to be inside of here, actually. Can't really get to. And in here, it validates the range based on the palette length. So our palette length is 0 because it's a color converter. Yeah. So, basically, let's create this here. And then go again with the if the type is palette. Do this. My IDE does not want to just use the right indentation. It's kind of a to be honest, I'll be honest, this is C line, which is like the PyCharm for C code. I don't know if the CircuitPython project is just too big for it or what, but I have found it is like not nearly as helpful as PyCharm, if I'm honest, as far as like even simple things like in PyCharm. If you put your cursor on a parenthesis, it will highlight the parentheses buddy, right? It will highlight the one that the syntax highlighter thinks is the match for that, which, like, sometimes your code has an error and it's not what it's supposed to be. That highlight makes it easier to find. It will do the same thing for curly brackets. Obviously curly brackets not a thing in Python too much, in dictionaries, but it will, but this one just doesn't do that. And things like the indentation, like this whole file is 4 indentions, but it wants to do 2s. Whereas PyCharm is pretty good about all of these things. I don't know if it's like just this IDE doesn't do that. Like maybe C code is harder to syntax or whatever, syntax highlight. But I have found that there's way fewer training wheels, so to speak. the sea lion one. I should update it as well. That's the other thing. Like, these things are always getting better. I don't usually update them that quickly. So, probably is better than the newest one too. Okay, if it's a palette, we set it to that. Else, if it's a color converter, we're gonna do this one. And in that case, palette length, it really just needs to be max 32 uint, whatever that is. I don't know, how do you find that? Uint 32 max. Because if you're using a color converter, then you get the entire uint 32 basically. So another efficiency thing we could do, in addition to the null for the no mapping, would actually be to like selectively. Oh, that's going to be so hard though. I don't think I'm going to do that. Sorry, I know I didn't actually finish saying it. That's maybe the best time to realize you don't want to do it. Basically, the road I was going down in my head though was like, maybe it could selectively be uint 16 if you chose palette and uint 32 if you chose color converter. That's going to be so hard though, right? Because at the end of the day, it needs the struct which has the pointer thingy which is set to a type, right? We can't, I mean, I guess we could do both, right? We could give it a double pointer of uint 16s and a double pointer of uint 32s and just not use one, I suppose, but that doesn't feel so great to me either, so I don't know. I think we'll keep it at 32. I think that should let us color convert it, hopefully, at least. Like, set the mapping at least. Let's see, palette length was declared here. Yeah. Maybe used while it's uninitialized. Okay, so it's mad that I... Oh, okay, actually, so we have if and we have else if. Technically, we should have an else also. Otherwise, it could be not declared. In our case, there's not actually technically a possible else case, so I guess what I'll do is this. Can you just use int 32? It's a bit of a waste if you only need an int 30. You only need an int 32, but not a ton. Possibly. You only need int 16. So we need 16 when it's a palette that you're using, but we need 32 when it's a color converter. That makes sense. And they are, I mean, they're currently uints. They're always positive. Which they, I mean, yeah, they have to be always positive, right? Because they are either like a, whoops, they are either an index into a list, which is positive, or they are a color, which is also positive. It's numerically represented. So int 32 numbers 20, int 16 num 16, int 16 numbers. Interesting. Okay, so numbers is an array that holds 20 int 32s, and then num 16 is a pointer which you cast from numbers. Interesting. Okay. Does it still would store, it would still use the RAM required for int 32s though, right? Or would it actually, by doing that casting that way, does that like lessen the amount of RAM even though numbers was declared as int 32? M16 would hold 40. Oh, right. Yeah, it would just keep going past the end because that's how C is. Okay. Right. Okay, so then we could basically use like half the length the palette case. Okay. Okay, maybe we'll do that. That sounds way more doable than anything I was thinking of. So we would basically declare it as uint32. If it's a palette and we actually only need uint16, we can just pretend that it's half the size that it really is. We can pretend it's half the size. And then we're storing it in a space we allocated for uint32s, but we've casted it over. And because we pretended we have half the size, we end up using up all of our space. But then when we need the 32s, we go full size. That's pretty smart. Thank you for that. Unless you dynamically. So once we get to the null thing, then we will be dynamically allocating. Right now, it's just allocating it all in the make new, pretty much. But eventually what we'll have, what I hope to have is you can set a mapping to none, and then on the C side, it will set the pointer to null and free the space that was used by that mapping. And then if you go and set it to a new mapping later on, of course, we'll reallocate some space for the new mapping. But that's going to be after color converter, because I also think I will break it when I do that. Yeah. Does this build currently? Well, it does. It built. I ran it, and somehow we managed to get even further away, because now this says 0 to -2. It's awkward. Should this be a -1 or? Oh, we're getting -1 here. I don't have much confidence that just throwing a -1 there is going to work, but I mean, amount of times in my life where that's worked is not 0, so maybe. Even say 256 values at 2 bytes each. Yeah, it is not going to be ultimately that many, I think. It's based on the input, it's based on the number of colors in your input bitmap, which I think are often going to be 2. The most common use case, just black and white. Even in the case where it is more than 2, I think 256 is also a common limit. I don't know if that's actually the limit for bitmaps or if it can go higher, but like in GIMP, I know that's the default size of your palette anyway, is 256. So yeah, now we're down to -3, so this is definitely not working. Hmm. If I just say 0, but that's going to go to -. Why are we getting to -1 anyway? It's an unsigned int. Am I crazy there? Shouldn't we not go to negatives? Huh. I do not understand that. Well, this is okay, so this is about iOS. Maybe this is not the right thing for not iOS. Google instead. Can you just put hex in C code or no? In Python you can. You just put that in there? C doesn't do type checking. You can have a uint 16 equals 0 and then go a equals -1 and will happily. But it's not wrapping around though. It's going negative. But yes, you can put hex. Okay, hex will be convenient. But it wasn't wrapping. Like, if a was 0 and then a -1 and it will wrap to the top. But in my case, presumably we were getting 0 and then minusing 1 and going to -1. And then later on, I minused 1 and we ended up on -2. And then I minused another one. We ended up on -3, I think. Oops, I keep double clicking reset, but it's actually just a single click with the boot button. And I also keep making instead of. But this is the wrong size still anyway though, right? The maximum color should be 6xfs. Realistically, we don't want the max, so technically we're using uint32 because that stores the thing we need, but we're not using all of it. There's still 4 bytes we don't need. We just can't fit it in 16. I think this is actually what we want though, but what is the error now? What does it say? See, so now we're still back to -2. So we still are getting some kind of going negative. But let me try this anyway. Now that we don't actually need the max, maybe this is less of a problem. -1 is the same as maxent. We're close. So like it just can't represent it when it's printing? Okay, that one seems to have worked. So happily, I think since we're not using the entire of the uint32, we don't actually need to be at the very tippy tip top, which makes this whole problem less of a problem. Which is quite nice. I have no idea what to do about that. Yeah. So that is working now. Theoretically, we could set the mapping. So by default, we don't see anything because we've mapped. We only have 2 colors and we've mapped one of them to black, which we can't see because we're on a black background. And we mapped one of them to like the darkest blue possible, which we also can't see because it's basically black. But I believe now if we, let me keep this line and the one here. We should be able to now go like this. Theoretically. Yeah, look at that. Okay, that is the background though. I would like the foreground, I think. Nice. That's actually pretty sweet. Okay. Let's test the bounds. So that's kind of in the middle. We should be able to do red like, well, we should be able to do all the way white, in fact. Well, let's make sure red is fine. Sometimes red and blue are swapped. Let's make sure that's not going on. Okay, that's good. Just gonna test pink as well since we've done green and red. This will give us the ability to do blue as well. And then white should also work, even though that's not technically changing anything. Oops. Might be off by 1. 166. Yeah, we're off by 1. Yeah, because we're subtracting 1. So actually, what I'm gonna do is just plus 1 because we want to subtract from 1 when we're using a palette because the length of the palette it's 0 indexed based, so you can't access the 5th index of a palette that has length 5, right? You can only access the 4th index. So that's why the -1 is there. I guess we could put the -1 in here. Maybe what we should call, actually, here's what we should do. We should call this palette max. Let's call this palette max, not length. And let's put it in here. So this one won't have a +1. This one will have a -1. And then we'll do this here and we won't put anything here. That sounds better. I'm digging these quick builds. The first one took a minute, but the rest of these builds have been like 5 seconds. Like super fast. It's really nice. It takes longer to copy it than it does to build it. I guess that kind of stands to reason. Okay, there's our white. Nice. Oh yeah, I keep getting thrown off by this closing my CodePy. Okay, cool. So now I think actually what I'm going to do is just TPM rainbow so that we can save that version of this, and then we're going to go and start changing this. Actually, let me call that TPM rainbow palette because that one uses a palette. Started changing it for color converter, but the actual code that is currently commented out that does the bulk of the stuff is using palette. So color converter, though, we'll use now. Just leave that alone, I think. And then here, what we will do is we no longer need to do like we no longer want to do this. Instead, what we want to do offset starts on 2. So we don't even we don't need to start on 2 anymore because we're not worried about. So the reason that was 2 is because 0 was black and 1 was white, and then the next 256 indexes were the rainbow colors. We're not in a palette anymore. We don't have 0. 0 technically is still black, but 1 is no longer white. 1 is now really dark blue, dark enough to not be visible, and white is all the way at the opposite end. But we start on 0, and then what we're gonna do is set it to color wheel, rainbow IO, color wheel, the current offset. So we were previously using color wheel to preload a palette with all the rainbow colors. Now we will just use color wheel right in line here to put our hex color into the mapping. And then this will add some stuff. We can wrap to 256 now. And we don't really need the max thing anymore either. We can just do that because we're not... I mean, yeah, no, we don't need that anymore. We don't need that. In fact, we don't need this either. And then this is mad because now we have parentheses that are useless. Okay. Oh, we do need to add 1 though. I don't know. Somehow I got rid of... Oh, I was adding 2 before to make it just rainbow faster, I think. Make it change a little bit more between each character. 256 shades of color is actually kind of a lot. We could do 1 though. Let's look at what 1 does. Yeah, we don't need max though. Okay. They don't spawn white this time, but that makes sense because before they had that index 1 to make them white, and now we don't have that, but it totally is working. And it goes slower essentially, right? It takes it longer, takes it twice as long to get through the full rainbow. I think is why I had these here, just to kind of speed up the color change a bit. Well, twice as fast. Okay, that is awesome. That is the same thing visually that we had before, but now it's with a color converter, and technically we actually have way more degrees of freedom in terms of the color, right? Before we were in that palette with 256 colors, 258 colors actually. Now we have the whole 888 color space. It's gonna get compacted to 565 in the background, or 6565, yeah, whatever it is in the background, but okay. That seems functional. Let me look at the changes. Is there anything that stands out about what we've done that's like definitely want to change? So color, we allow color converter now. Okay, we'll eventually still go change that to pixel shader. Let's make sure this works on the type. I mean, I know it worked before when we changed it to a color converter, but let's just make sure. Like, if we gave it a string, it should fail, right? If we gave it a number, it should fail. Give it anything that's not a palette or a color converter. This is the code validating that. And then we do not have the ability to update the palette. So palette is only set from the constructor right now. So we don't have another place where we need to validate it. Only the constructor. Let's make sure that we can get it back off of there and it's correct. So if we go TPM, if we go print the type of TPM.palette, we should see color converter. Yes, okay. Size, yeah, that's another weird thing. The IDE just does not know what to make of size for some reason. Wait, where's my changes? All right, we changed that to uint32 so that we have enough room. We store our color converter values. We changed our allocations. We say if it is a palette, then we initialize the mapping to essentially no mapping. Every index maps to itself. If it is a color converter, we just default all to 0, which is going to make everything black. I guess we could default to white. Is that better? No. I mean, still the problem is it's going to be every pixel, right? You're not going to be able to see your image. You're just going to see a white block instead of a black block. I don't think it's really that different or useful. So I think we just leave it there. Essentially, when you use color converter, you're kind of on the hook for setting the first mapping. You have to do it before it's really useful, essentially. And as a consequence, there won't really be a similar concept for when you're using color converter, there's not going to really be a like null mapping. I mean, I guess you could do it, but it will make it so you can't see anything. And like as we talked about before, there's no clear behavior. There's no clear like what even should the null be, right? Because for palette, it makes sense. 0 maps to 0, 1 maps to 1. Everything's all happy down the line. For color converter, it doesn't make as much sense because you still could have a 2-bit bitmap or a 4-bit bitmap or whatever, but you're going to have to map each of your input color indexes to a color, and there's no way to default that. There's no way we can know what index is supposed to be what color. Yeah, user has to tell us. Okay, we changed this to palette max instead of length, which is good. So now we have our -1 there. We don't need the +1, and we no longer need the -1 down here. We, inside of get color, now check the type. If it's a palette, we do the palette thing. If it's a color converter, we do the color converter thing. So this is actually only if it's out of bounds, if the tile that was requested is actually out of bounds of the TilePaletteMapper. And then down here, same logic, checking for palette or color converter, but this time it's the tile is actually in bounds. So we have gotten the input pixel from the tile, and we're able to map it because our mapper is actually big enough. So we get our mapped color value, and then we go either figure out what color that is from the palette or get that color from the color converter, convert that color in the color converter to 565. Yeah, that's all looking pretty good, I think. Next, we did change that. Yeah, and that's fine. All right. That seems all good. I got to run to the restroom. I'll be right back, and then we'll keep going. Okay. About 20 minutes. I think what I will do is try to build the docs and run pre-commit and see if we have more stuff to fix or not. Can't be found. Ooh. I had this happen earlier. Yeah. I'm pretty sure this means we have a tab. I totally had this happen before where like our formatter is supposed to update the file with the correct format. Like, I don't, what is even happening here? I don't even know what this is done. This is just like, its mind. And in addition to having lost its mind, it also like changes the file, but then fails the next, like it's never getting itself to a state where it passes. Usually with pre-commit and the formatter and stuff, like you run it once, it updates the file to be valid, and then if you run it again, it passes. But I'm like stuck in this fails instead of passing. I'm pretty sure that this is because of this. I think, how far back? It should be like all the way back, I think. Okay, it's in line with that triple quote. I don't know. The spacing there is probably what wrecked it, or maybe the missing type character wrecked it. So we're gonna try to help it out here. What do we? That's better. I think either and or both the extra indentation there, or the. I guess I was missing a pipe. Maybe it was unhappy. We'll see if the docs are happy though. Sometimes that's different thing. What are you working on? What's up? First of all, over in the YouTube Blue Fox Inc. Studio. Has the bottom YouTube chat just been cut off this whole time? It's my bad. Sorry about that, folks. Yeah, first of all, hello and thanks for watching. I am working on, so I don't know how familiar you are with the stream overall. The high level thing we're working on is CircuitPython. If you don't know what that is, let me know. I can give you the quick rundown. Much deeper into the weeds within CircuitPython, I'm working on a module called TilePaletteMapper, which lets you take an input bitmap that is of like a low number of colors. In this case, our input bitmap is just 2 colors. It's only black and white. And our bitmap is the font bitmap, essentially, that we use for labels. So that's why we have characters and numbers and letters. So that is a 2-color bitmap, only black and white. But this module that I'm working on, TilePaletteMapper, is allowing us to go and change every tile inside of our tile grid, which is what these are laid out in. We can change every tile to remap the colors to a different thing. So we can say, whenever you find a pixel that would be white, instead make it green, or instead make it blue or pink or whatever color, whatever shade of whatever color we want. So that's how this is doing this whole rainbow chameleon effect thing here, is going through and updating all the white pixels to be like green or, you know, blue or red or pink or whatever. Always turning on slow spaces, show spaces. Okay. Did this build? No. And the docs are doing this cool thing where the error is like 1,000,000 miles away. Okay, there it is. Tile index field list ends without a blank line. Okay. And I mean, we have this blank line, but clearly that's not cutting it. So maybe we need the indentation also. So one thing that is kind of helpful, this is telling us index RST 509. We can actually go over to shared bindings and look at this. It is HTML. Well, it's RST, but it has these in it, which are HTML. But actually not, because it doesn't have closing tags, which I didn't notice before. That's interesting. 509. Okay, yeah, totally this one's messed up. I think that we need the indentation, probably. Probably we wrecked it with the pipe before. And I took away both the... Well, I took away the indentation, I added back the pipe. I think we need the indentation and the pipe. Docs build slower than the core. Kind of fair though, it has to compile a lot of stuff, right? Like he's got to gank all of these comments out of all these files, turn them into PYI or whatever, and then run Sphinx on that. So it's kind of a lot of stuff. Go, successful. Run pre-commit again because now we changed the code a little bit. Learn my lesson with like, let me just change this one thing. Surely it'll be fine. It's like we're actually fine. It's always like you change one thing and that actually totally matters for pre-commit. My experience at least. Yeah, I'm gonna push this one. And this is on its own branch again, so I'm gonna push this one. I'm not gonna open the PR yet. I'm gonna wait for the PR on the other one to get merged and or get more feedback. But then after that does, I'll open this one and perhaps the null one if we get the null one working. Although we're definitely not going to do that today with 15 minutes. This is tile. So this is implement. Oh, should we change the name still? Let's go change the name. We got about 15 minutes. That's probably what this will take. So let's do that. So we are no longer, instead of palette, we are going to have pixel shader. The palette to get mapped colors. So this is going to say the palette or color converter to get mapped colors from. Yeah. Mapped colors from, yeah. I mean, with the color converter, that's not technically true. It's not getting the mapped color from the color converter. It's getting the mapped color from the mapping. It's passing it into the color converter to convert it to 565, but yeah, I don't know. It's difficult to make it technically accurate for both of those, but not a lot longer and like wordier. I don't have an eloquent way to put it. I think I'm just gonna leave it. The rest of that's the same. This will now be pixel shader here. We'll make it on this. Oh, that needs to be pixel shader here. We'll make it on the struct, also pixel shader. No longer have palette. Well, we do actually. This is palette, pixel shader. No, we don't. Okay. We're gonna have get pixel shader now. And get pixel shader here. Okay, that's not actually defined. That one's size, and this one is also size. Those are red. There. Okay. Not sure I knew that indentation equals indentation. Indentation. I've always used the latter, indentation. I don't know. I tend to, so I've never really thought about the difference. I tend to go with indentation. I'm not sure if there's technically a difference or not. English is weird like that sometimes. There's some words where it's like totally different words mean the same thing, and there's some words that are like almost the same, mean totally different things. You're like, remember that, I guess. Okay, get palette here. Okay, we're gonna want to search this in a minute for all the self dot palette, self arrow palette, technically. Actually, this will make it easier to find them, I think. Yeah, now they should turn red, actually. But it will still be easier to fix them this way. Size. Okay. Did I forget anywhere? I think that we got everywhere, didn't we? It is a bit weird now that our name has palette in it, which we just went and changed all palettes to pixel shaders. So it could be tile pixel shader mapper, I suppose, but I think I'm going to leave the name of the module and everything. I would have to change a lot more to do that, so we'll leave that. I mean, in my mind, palette still makes sense, right? Because ultimately we're mapping from the colors in the input bitmap, which is still kind of a palette. Yeah. Wonder if folks find English to be such a hard language to learn. Yeah. Okay, does it build? This is the wrong tab for building. Got back to a slow build. I think it depends on what you change. Some things you change, you still get a fast build. Other things you change, you got a slower build. All right. Very slow build here. Maybe I shouldn't have given it props on the fast builds yet. I don't know. We'll get back to it. It's just like, maybe because we changed shared bindings instead of just shared module. There it is. We are getting down to the last couple minutes, so if anyone has questions, comments, anything like that, now's the time to get them in. Also, I guess now is a convenient time to do the old, oops, while we're in bootloader, let's copy that. Do the old rundown of upcoming shows. So, for anybody that doesn't know, normally I stream on Saturday mornings at 10 a.m. Central Time. So like tomorrow morning at 10 a.m. Central Time, Central US. Tomorrow I am out though. No stream tomorrow, but I should be back next week at the normal time, Saturday 10 a.m. So then, yeah, no stream tomorrow from me. But next Friday, 1 week from tonight, I'll be back for Deep Dive at the same time. And then 1 week from tomorrow, I'll be back at my normal time of 10 a.m. Central Time over on my own channel. Not the Adafruit one here. Okay. So that is flashed. This is running. It is going successfully. I was going to say we could make sure it worked by passing the wrong type of thing and the error message will say pixel shader, but it actually said that before anyway, so change. That's just the error message we gave it. Well, because I added a validate, and the validate must just, well, it's inside of I think it's inside of tile grid, so it just uses the generic name pixel shader. Yeah. All right. Pre-commit docs one more time since we made a few more changes now. As long as that's good, we push, and then I think we wrap it up for the night. Thanks for the stream. Sorry not to have one tomorrow. Yeah, we'll be back next week. Tomorrow, I got some other stuff going on. Tomorrow's my anniversary, so we'll be hanging out with my wife. We got a couple of fun things. We go out, have some nice food, and hang out for the day. Be a good day. But we'll be back next week at the normal time. Just jamming out over here. Got music going in my ear. Thank you and great work. Yeah, for sure. Thank you for watching. All right. Yeah, we're good there. So I will push this. Implement color converter. Let's say, yeah. Palette. Happy anniversary. Yeah, thank you. Okay, yeah, this is a weird thing that this does. This is another weird thing that Sea Lion does, which PyCharm doesn't, or it might be the submod. Like, there's a lot of these are all submodules, I'm pretty sure. So I don't know that it's actually a Sea Lion problem, and it's just the core has all these submodules. But it shows me this, which is kind of like, I don't know why all these are listed here. But then we get down to here, and this is the one we actually want. I do want to change the remote to be Foamy Guy. And then, yeah, now we're good there. So we have that. Those are only our changes. All right, yeah. If anyone is interested in playing along with this stuff, the PR is open with the original version, which supports Palette, and then I just pushed, obviously, the new one, which is on my fork of CircuitPython under TilePaletteMapper color converter. If you want to play with that before the PR gets merged. The PR, the one that's open, is palettes only. This one has got color converter, so that's even further down the road. But if you want cutting edge, there it is. Thanks again to everyone for watching. Thanks to all the folks in the chat who gave good ideas and helped me out along the way. I appreciate all of you. Yeah, again, we'll be back next week at the normal deep dive time, which is 2 p.m. Pacific, because that's where Scott's at. So it's usually billed as 2 p.m. Pacific. That is 5 p.m. Eastern, which is where Adafruit's at over in New York. So 2 p.m. Pacific, 5 p.m. Eastern. And then I happen to also actually be in Central. So when I am here, I tend to say 4 p.m. Central because that's what time it is for me. So 2 p.m. Pacific next Friday, 5 p.m. Eastern, 4 p.m. Pacific. Daylight savings time might be happening also. I'm not sure. That's coming up. So maybe we're shifted. If you're in a place where daylight savings time is different than the U.S., check that out. We might be 1 hour off from where we are this week, or maybe that's next week. I'm not sure. Whatever. It's coming up though. So somewhere here we'll switch. And then next week, Saturday morning, 10 a.m. Central, we'll be back. Thank you again, everybody. It's been great. I will see you all